Welcome to today's Explainer. We're about to unpack something truly fascinating in the world of modern software development. We're looking at a proof of concept web app called ServiceFlow Lite. On the surface, it's just a basic tool for HVAC crews and handymen to track their jobs. But underneath that simple exterior, it is secretly serving as a masterclass in disciplined, multi-agent AI software development. We're going to explore exactly how a crew of AI agents built a functioning app without losing their minds or the code base.
It is the multi-million-dollar question in tech right now, isn't it? Can AI actually code a complex project without hallucinating new features, breaking the old ones, or just drifting wildly out of scope? I mean, we've all seen AI prototypes that look amazing for about 5 minutes before turning into a giant bowl of spaghetti code. Okay, let's dive into this because the source material on ServiceFlow Lite reveals a system that answers that question with a resounding yes, provided you have the right guardrails in place. Real quick, here is our roadmap for today. 1. The AI software factory. 2. Building the app foundation. 3. Phase 4 hardening. 4. Fixing flaws, preventing drift. 5. Centralizing error handling. And 6. The final checkpoints.
Section 1. The AI software factory. Beyond a simple app.
This app is essentially a laboratory perfectly disguised as a service tool. The entire operating model relies on a full staff of specialized AI agents, and they are bound by a really strict rule, the separation of powers. So blueprinting doesn't mean coding, coding doesn't mean committing, and committing doesn't mean pushing. What's really interesting about this is the strict approval process. By using separate gates, it physically prevents scope drift. The AI can't just run wild and push code, it literally has to ask for permission at every single gate, which maintains an absolutely pristine Git history.
Section 2. Building the app foundation, covering phases 1 to 3.
So you're probably wondering, did this heavily guarded process actually produce a working app? Yes, it did, in 3 very methodical steps. Step 1 was the foundation, locking in those basic data models for customers and jobs. Step 2 brought the operational workflow, giving the app its rhythm with job statuses, search filters, and a history timeline. Step 3 added the dashboard, bringing in that crucial management layer for metrics and visibility. By the end of this 3rd phase, we aren't just looking at a toy prototype anymore. It actually has real business-facing utility.
Section 3. Phase 4. The hardening, controlling the product. Now, this is where the training wheels completely come off and the project starts behaving like a rigorous software product. To prove just how serious this process is, look at this number, 787. Going into the latest phases of hardening, these AI agents had successfully written and maintained 787 passing tests. Think about that for a second. An AI didn't just write the code, it wrote, executed, and maintained nearly 800 tests to prove its own code works. That is a massive credibility boost for this disciplined approach. The hardening phase was broken down into very specific modules, starting with Module 4.1. The crucial point here is that this module acted as a pure test gate. The AI was tasked with closing coverage gaps and adding edge cases, but with a strict rule. It was not allowed to alter a single line of application code. Nothing in the app directory was touched. They even used a date/time sentinel in an assert-only mode, basically freezing time in the testing environment to lock in stability before any further coding was allowed. It was a complete lockdown.
Section 4. Fixing flaws, preventing drift, Module 4.2. With the baseline totally locked, the new goal was solving specific bugs without expanding the scope one bit. First up, this crazy phone number issue. Before this module, a user could theoretically put in a phone number with over 4,000 characters, like submitting a small novel instead of a contact number. The AI fixed this easily by adding service-side rejection and bounding the input to just 32 characters on the form. Second, they caught a critical flaw where updating a job could bypass the normal status rules. The AI's fix? It stopped the update job function from writing the status entirely. Let's look a little closer at that second fix, because it is a huge deal. Before the AI jumped in, if a user updated a job but accidentally left the status field blank, the system would just silently downgrade that scheduled job all the way back to new. Yikes. And this brilliantly illustrates a strong architectural decision by the AI workflow. It isolated the job status updates. Now, only the change status function can write to it. This completely eliminates the risk of a silent downgrade. It's elegant, it's contained, and it's highly professional engineering.
Section 5. Centralizing error handling, Module 4.3.
Next up, the agents were tasked with replacing those default, kind of ugly Workzeug arrow pages. They successfully implemented handlers for all the major errors using just one shared template. But honestly, what is most impressive here is what the agents intentionally didn't do. AI loves to add unnecessary things, right? But here, the agents kept the real route map completely untouched at exactly 13 routes. To test the 500 server error, they didn't add a dummy route to the live app. Instead, they spun up a throwaway app instance right inside the test file. Zero scope drift, while still proving the error handling worked perfectly. Section 6, the final checkpoints, looking ahead.
So, the foundation is built, the hardening is mostly done, and all the repositories are perfectly in sync. Next in the queue is Module 4.4, the security review. And this is highly constrained. The AI will audit parameterized SQL, cross-site scripting, CSRF, and secret handling. It's specifically looking to generate a security evidence document and apply narrow cookie hardening, like setting same site to lax. It is strictly forbidden from adding new dependencies, rate limiting, or doing any deployment work.
Let's move to the next part and see how this builds, because this is their ultimate safety net. The golden rule for Module 4.4 is this. If the audit finds a real exploitable defect, the agent must stop and escalate before fixing it. This strict escalation rule is just brilliant. It ensures that a routine security review doesn't suddenly spiral into a massive uncontrolled AI refactoring session that rewrites half your application while you aren't looking. Once security is totally cleared, Module 4.5 will handle the final polish. This is where they finally let the AI clean up the deferred items that just weren't critical earlier. Things like clearing out some dead code in the list jobs function and fixing a weird visual bug where timeline timestamps were rendering as raw UTC ISO strings instead of user-friendly text. It's the final documentation and project closeout. When we step back and look at the whole picture, the key takeaway from the source material is perfectly summarized by this quote. The ServiceFlow Lite app itself is useful, for sure, but the process is the real product here. By establishing strict module boundaries, repeatable test gates, clear scope sentinels, and those vital separate approval gates, a small AI crew can indeed operate as a disciplined software factory. It doesn't have to be chaos. And that leaves us with a pretty critical thought to close on. We've seen today that AI can absolutely write clean, tested, and secure code, but only because the workflow surrounding it was incredibly rigorous. If you just unleash AI on a loose, unstructured codebase, you're going to get a mess. But if you enforce strict, sentry-guarded constraints, the results are incredible. So ask yourself, is your current development workflow disciplined enough to manage a crew of AI coders? It's something every single engineering team needs to be thinking about right now. Thank you so much for joining me for this explainer on ServiceFlow Lite. Keep learning, and I'll see you next time.